So just a quick review of what we know. We know how to factorise quadratics and to solve. As an example, if I had this function here and I asked you to solve it, what would I be asking you to do? What's your first step? Normally solve means we isolate the variable, but when we see solve with quadratic, what do I have to do? I have to let y equal. What do I have to do? Let y equal. And then I'd have 0 equals. I'd set up two brackets, correct? What would go in front of those brackets? Then what do I do after that? What's the next thing I write in my brackets? The signs. And what can you tell immediately by looking at this quadratic expression? One's positive and one's negative. And how did you know that straight away? Only way you get a negative for that last number is by multiplying a positive number and a negative. So we want two numbers that multiply to give us 32 that are separated by 4. So I asked myself, what are the factors of 32? 16 and 2, that's not it. 32 and 1, that's not it. 8 and 4, that sounds pretty good. Which one's bigger? The negative number? Which one's bigger, the 8 or the 4? Which is the bigger of those two numbers? Which one's bigger, the negative or the positive? Oh, sorry, which, like, in this expression, would I expect the larger number to be negative or positive? Sweet. Happy with that? If this was a positive, obviously it'd be the other way around. Now, I've solved that expression sort of. What have I missed out? There's one or two steps I've missed out. Applying the null factor law, and that's just saying to get 0, I have to multiply. One of these things must be 0, correct? So in the situation where this is 0, x is equal to 4, or negative 4, x is equal to 8. Happy with that? So we know how to do it. We're very good at solving those quadratics. If I was to look at your data across your education perfect tasks, or just anecdotally when I walk around the room, I'd say that as a group, we're pretty good with that. Some of us might need a bit of work, but that's okay. When I say key features of a graph, what does that mean? What do you know that I'm talking about with the key features of a graph? Turning point. That's specific to parabolas, but because we're talking about parabolas, absolutely. So turning point's one of the things that I need. What's the other thing that I need?
Intercepts.
Intercepts. That's that other thing, that there could be multiple intercepts, obviously. But they come in two forms, intercepts. Y-intercepts or X-intercepts. How many Y-intercepts will we ever see? 1. How many X-intercepts can we see? 2, 0, 1. Could be any number. With a quadratic, it could be 2, it could be 0, it could be 1. Happy with that? Awesome. And we know how to sketch quadratics in the form y equals a minus x minus h squared plus k. H represents our what? Yep, well, when you say x, I know what you mean, but we're talking about our, it starts with h, the word that I want. Horizontal translation, which just means I'm picking it up and I'm moving it. K represents our vertical translation, and I can't spell the word vertical, but that's okay. See if I've got it that time. Nope, haven't. It's a, I don't know. Good, see you pass the test. Vertical translation, and A represents mine. Dilation. What can I also do? Flip it and reflect it. Sweet. So we know all those things, and I'd say that most people are relatively comfortable with that. Now the good news about what we're learning today is that it's just that. It's what we already know. It's just applying a different lens on it. And if you're struggling with one of those things, that's fine. That's why they pay us to teach you, because you don't know it all initially, and it's our job to change that. When we look at functions today, we're looking at as functions in the form y equals x minus b, x minus c. What do you think would be, if like I was writing a question, what would be replaced by numbers here? B and C, okay? And we call this intercept form because an intercepts can easily be identified. Why do you reckon intercepts can easily be identified? If I was to look at, does that look pretty similar, what I've got there, does that look pretty similar to something like, I don't know that?